How fast can I move in miles per hour? Well, that's an interesting question. And I used to actually like to calculate a lot when I was in school. I would actually ask my friends to run a certain distance. We'd figure out how far they ran and the time it took to do so. Then we'd convert that to miles per hour. To do this, we're looking at two different units of measurement. We're looking at a distance from point A to point B, and we're also looking at time. When you have more than one unit of measurement working together, that's called a compound unit. Compound meaning putting more than one thing together. So, a compound unit of measurement, in order to convert with those and to measure things with them, you need to know all the other conversion factors. So you need to know what they are for distance. You need to know what they are for weight. You need to know what they are for capacity. You need to know what they are for area, for volume, or how to get to area and volume from just using distance. Because we talked about that, and so it keeps it simple if you only have to know three as opposed to five. Much simpler to know three and just know that to get to area, take distance and square it. To get the volume, take distance and cube it. Okay? A lot less to try to memorize up here. Anyway, let's get back to my initial question. How fast do I run in miles per hour? So let's say I go out. It's been a while, but I used to run track. And I go out on the track. I do my 1600 yard dash. And after I get done with my 1600 yard dash, I clock in my time. I've gotten a little slower. It's taking me 6 minutes. All right, so 1600 yards was done in 6 minutes. So 1600 yards was done in six minutes. Now, in the end, I want to know, the question is, how many miles do I run per hour? How many miles do I run per hour? If I keep that same pace, of course. So, we want to know how fast I was going if they were to clock me in with one of those speedometers. Cops might have to pull me over pretty fast. So, if I look at this, though, I'm going 1600 yards for 6 minutes. An easier thing to look at might be, hey, how fast is Professor Stevens going per minute for each minute? So it's 1600 yards for 6 minutes. How many yards is it for just 1 minute? Well, how would you figure that out? Well, to get 6 minutes down to 1 minute, you would divide it by 6, right? And then this would get to 1 minute. So if I do that, I end up with, well, let's see, both of these numbers can be divided by 2. So if we do that, we get 800 over 3 yards per minute. Notice I put minute in the denominator. Well, if you do yards per minute, that's actually yards divided by minutes. So this is our starting point here. 800 yards per 800 divided by 3 yards per minute, or 800 yards per 3 minutes. I could have actually started out by just putting in 1600 yards per 6 minutes here, but I didn't, just because if you simplify it now, it'll make it easier when you get to your conclusion. All right, so we started here, and now we're going to do that dimensional analysis. Yes, it hasn't gone away. What do we want our answer to be in? We want miles per hour. And as we just talked about, per means that the first one's going to be our numerator, the second one's going to be our denominator. So we want to have miles in the numerator in the end. And we want to end up with hours in the denominator in the end. Okay, this should be fairly simple then. Well, how many miles do we have for yards? Or vice versa, how many yards for miles? Whichever one you know. Well, we know how to get that because we have our conversion factors. And I wrote them up here again, but I'm sure by this time you probably have already memorized them. So we have our yards. We know that there's 1,760 yards for 1 mile. Okay. And for our hours, going from minutes to hours, we know there are 60 minutes in 1 hour. So I can put minutes up here, 60 minutes for 1 hour. Well, Mr. Stevens, normally you put what you're looking for up here at the top. Why did you do that differently here? Well, let's see why. If If I have my yards and yards, they cancel very easily, right? Because we want them to go away. Because remember, the only units we want to end are miles per hour. So we want miles in the numerator, hour in the denominator. Well, what about these minutes? It started off in the denominator. I put one in the numerator. Now it can cancel. And so all I'm left with is miles and hours. So we're good to go. Now, as I said, reducing this earlier on makes it easier to simplify later. So let's see what we end up getting now that we have this. So if we were to multiply and divide, we'd have 800 times 60 divided by 3, then divided by the 1760. And if you were to do that, you would end up with 100 over 11 as your fraction. 100 over 11 miles per hour. Or we can approximate that, and we get that I'm going 9.09, repeating, miles per hour. That's pretty fast for a human, I think. It's not really, but I can say that I'm pretty fast. So that's a pretty cool thing that you can do. You can see how fast you're going miles per hour. Some other things you can do is that you can check, hey, let's see if these measurements they have on these bottles are right. I can find out the cubic inches of this, or I can find out how many ounces this holds, and then measure how many inches I go up on here. For instance, on this guy, this is 6 inches high. And according to it, going from its bottom to its fill line, it's 32 ounces. So it's 6 inches high to that fill line, and it's 32 ounces. So 6 inches will equal 32 ounces. So I can figure out how many inches on here would be on each ounce. Well, how many ounces would be on each inch. That's a cool thing to measure. Because then we'll say this fades away, or I just want to see how much have I been drinking, but it's now on one of the fill lines, and I don't feel like chugging myself to get there. I can measure out how far away, how many inches have I moved down, and figure out how much I've drank that way. Interesting, right? So, in essence, when it comes to compound units, just remember that a compound unit has more than one different units of measurements. So it'll be combinations of measuring distance, area, volume, capacity, and weight, all in one. They can throw in other things too. If I wanted to know, say, hey, is my AC working properly? Because it's supposed to be able to have 24,000 BTUs in an hour. If you don't know what BTUs are, it's a British thermal unit. It tells you the amount of heat or energy it would take to raise 1 pound of water 1 degree Fahrenheit. Why do I know that? I have no idea why I memorize that. None whatsoever. I don't deal with AC. Some of you may. Some of you may in the future. Some of you probably own an AC unit that you never even knew that it did that. Anyway, so say you have a problem like that and you want to make sure it's working properly. You want to see how much heat it takes away, or see how the temperature changes in 1 pound of water that you have sitting out next to your vent or something for 10 minutes because you don't have an hour to wait to see. You can do these conversions here to figure that out. Now, I'll leave that up for you to do. But let's look at one more conversion that may look a little more complex, shall we? The AC unit one sounds more fun, though, doesn't it? Yeah. Okay. Your truck, because we used the truck problem earlier, let's say it can hold, in all its weight together, it's 3 gross. Okay? However, it's 3 gross, but its tires can only handle, let's keep it a simple number, let's do 50 psi, which is 50 pounds per square inch. Okay? Well, my tires aren't in square inches. My tires are going to be huge tires because it's a truck, right? Yeah. And let's just say that my tire is 2 square feet. Okay? So I have 3 gross for 2 square feet. I just made this up, by the way. I don't think the tire is going to actually be 2 square feet, just so you know. But I need to see if it can handle this. I need to see how many pounds am I putting on per square inch. All right, so let's figure out. I might need to get bigger tires, otherwise they might pop. So we have 3 gross. And we have her 2 square feet. I need to end up with pounds per square inch. All right, this is going to be very similar with what we did before, right? Okay, so when I do this then, how many pounds are in a gross? Well, since I'm going to pounds, I have gross. I know that 1 gross is 2,240 pounds. Okay, cool. Well, I'm going from square feet to square inches. Well, I know that 1 foot is equal to 12 inches. So 1 square foot is equal to 12 squared square inches. Remember that from area? We can take the distance and square it. It'll be easier than trying to remember what that value would actually be. All right, so we're all set up now because our square feet will cancel. Our gross will cancel. And so we have pounds and square inches left. All right, let's see what we get. Already looking kind of big there, right? I think my tires are going to pop. All right, so we get 3 times 2,240. And again, that would be 6,720. And we can divide that by 2. And then divide that by 12 squared. And we end up with 70/3 pounds per square inch. That's not too bad. Maybe they won't pop. Well, let's see. Let's reduce that to make it a little easier to see. We know that 3 can go into 70. How many times? Come on, you did division. Come on. What is it? What is it? Yeah. Yeah, that's right. Okay. So we get 23.3 repeating pounds per square inch. I got 50 pounds per square inch in here. This can handle it. It's only putting down 23.3 repeating pounds per square inch. Now, why is it important to make sure that 0.3 is repeating? So let's say that our PSI, or pounds per square inch that our tires can handle, was 23.36. This is just right underneath that. All right, so we get to go. Or let's say we had 23.4. This wouldn't work anymore. Or if we had 23.3, this would be too big, right? Because the 3's repeat. So these are important things to remember when you're doing your conversions. Another thing is that a lot of times when you're doing conversions, significant figures is the part that matters most. And so you'll use your significant figures rounded in your final answer, not along the way as you multiply. Remember that. It's in the final answer that significant figures matter. All right, I think we've done enough with compound units. Go out and have some fun with this. Some of you are painters, and you can see, hey, every time I put my paintbrush in here and I do some drawing or something, how much am I using? If I use the same amount for just about on average for every painting that I do, how much am I using? So I can know how many tubes I need to buy, or how many big things, big gallons, or big Sherman-Williams tanks with 3-gallon buckets or 5-gallon buckets I need to buy to paint my house or whatever. You can use these measurements when you're doing things like that. You can use these measurements and compound measurements in honestly anything you do. It's quite cool. Actually, most things you do are in compound measurements. You just don't really realize it a lot of times. For example, if you're cooking and you see your measurement says a cup, well, instead of doing that, most of the times mentally, like if you know you need 2.5 cups or something and it says a cup on there, you just go 1, 2, and you get half of it, right? Some of you will even, if you need 2.5 cups, what you'll do is you'll just grab the half cup measurement and do it 5 times. Why 5 times? Because you already know that if you, for every 1 full cup, you need 2 of them, and you have an extra half one there, so that's going to be 5 of them. So you're already doing these compound measurements without even realizing it. Kind of cool, huh? All right. Anyway, I'll see you soon.